A 502 bad gateway error in a Kubernetes cluster indicates that the Nginx ingress controller cannot successfully communicate with your backend pod. This failure occurs at the proxy layer, where the gateway receives an invalid response or no response at all from the upstream service. Locating the root cause requires the log stream from the ingress controller. Use the command kubectl logs, followed by the pod name and the specific namespace. Search for lines containing the keyword error to isolate the specific upstream interaction that failed during the transaction.
The message upstream sent no response, while reading response header means the TCP connection was established, but the application closed it without sending a single byte. This often suggests a process crash or a severe application error during the initial request handling phase. When logs show connection refused, the ingress controller cannot even open the socket. This signifies the pod is not listening on the expected port, or the networking path is obstructed by internal cluster rules. Verify the container port matches the service target port definition exactly.
Run kubectl get pods to check the status of your workloads. A status of crash loop back off means your application is failing repeatedly on startup, preventing Nginx from establishing a stable upstream connection. Check the specific exit code to determine the failure nature. An exit code of 137 indicates an out-of-memory kill. The Kubernetes OOMKiller terminates processes that exceed their defined memory limits. Inspect the last state of the pod using kubectl describe pod to confirm if resource constraints triggered the termination.
The readiness probe determines if a pod can accept traffic. If the probe fails, Kubernetes removes the pod IP from the service endpoints. Nginx then has no valid upstream destination, resulting in a 502 error if no other healthy pods exist in the pool. Applications with long boot times require a properly configured initial delay seconds in the readiness probe. Without this, the probe may start too early, fail, and keep the pod out of the load balancer rotation, even though the application is technically healthy but still initializing.
Check that your service labels correctly match the pod labels. Use kubectl get endpoints to see if any pods are actually attached to the service. If the endpoints list is empty, Nginx will return a 502 error because the service points to nothing. NetworkPolicies can block traffic between the ingress namespace and the application namespace. Verify that ingress traffic is explicitly allowed on the container port. A default deny policy will silently drop packets, causing Nginx to time out or receive a connection refused error. 502 errors can occur if the application returns headers that are too large for the default Nginx buffers. This is common with authentication tokens, like those from Keycloak. Increase the proxy buffer size and proxy busy buffer size annotations to resolve this. Mismatched keepalive timeouts cause intermittent 502 errors. If the application server closes an idle connection before Nginx does, Nginx might attempt to reuse that closed connection for a new request. Ensure the application timeout is always longer than the Nginx upstream keepalive timeout.
If the application takes too long to process a request, Nginx will close the connection and return a gateway timeout or a bad gateway error. Adjust the proxy read timeout annotation in your ingress resource to accommodate slow database queries or intensive background processing tasks. During a rolling update, pods are terminated. If a pod stops immediately while Nginx is still routing traffic to it, 502 errors occur. Implement a pre-stop hook with a short sleep command to allow time for the service endpoints to update globally.
Use kubectl debug to launch an ephemeral container inside the pod network namespace. This allows you to run diagnostic tools like curl or netcat directly from the target environment, bypassing the ingress and service layers to test the application binding and responsiveness directly. If the cause remains hidden, use packet capture tools to analyze the transmission control protocol stream. Look for reset packets sent by the application. A reset packet indicates the application kernel forcefully closed the connection, often due to a full listen queue or an application crash.
Sometimes Nginx cannot resolve the service name through the cluster domain name system. Check the core DNS logs for errors and ensure the service name and namespace in your ingress matches the actual deployment. Domain name system latency can also trigger intermittent 502 responses. Ensure your application binds to 0000 rather than localhost. If the application only listens on the loopback address, it will not be reachable from the Nginx ingress controller through the pod IP address, leading to an immediate connection refused error in the logs.
Systematically verify the pod status, check ingress error logs for specific upstream messages, validate service endpoints, and ensure probes align with application startup time. This logical progression isolates the failure point within the complex Kubernetes networking stack for a rapid resolution of gateway errors.